सो गाइज, वेलकम बैक। आज एक ऐसा प्रॉब्लम सॉल्व करेंगे जो जिन लोगों ने सॉल्व किया होगा उनके अकॉर्डिंग तो काफी आसान प्रॉब्लम होगा। बट ये काफी डिसेंट प्रॉब्लम है अगर आप इसको थोड़ा और सबसे पहले तो हम लोग इसका प्रॉपर सोल्यूशन देखेंगे एंड देन वी विल एक्सप्लोर सम पॉसिबिलिटीज अराउंड दिस। पहले क्वेश्चन कह रहा है, गिवन एन इंटीजर एरे of length n that represents a permutation of integers in the range 0 to n minus 1। इसका कहने का क्या मतलब है? परम्यूटेशन का मतलब अगर मैं बोल रहा हूँ कि मेरे पास एक परम्यूटेशन है ऑफ एलिमेंट्स फ्रॉम 0 टू n माइनस 1 और मेरे एरे का भी लेंथ n है, इसका यही मतलब है कि मेरे पास मान लेते 0,1,2,3 ऐसे करके करते n-1 चीजें होंगी और ये जम्बल्ड अप होंगी। what it means it won't exactly be in order, right? तो इससे एक डिडक्शन जो आप निकाल सकते हो कि all the elements will be unique because it is a permutation of integers। परम्यूटेशन में सारी चीजें यूनिक होती हैं जो कि आपको नीचे कंस्ट्रेंट्स में दिए हुए भी है, राइट? सो प्रॉब्लम कह रहा है वी नीड टू स्प्लिट एआरआर इनटू सम नंबर ऑफ चंक्स in and individually sort each chunk. After sorting each chunk, concatenate them. The resulting array should be a sorted array. And we need to return the largest number of chunks that we can make so that we can sort the array. Right? So what this question is saying, I will be given an array. Right? And now I have to break this array into some number of chunks. Let's say I have broken this array like this, like this, like this, and like this. Let us, I have made a partition here, 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 and this is an unsorted array. This is an unsorted array. Now this is my step 1. In the next step I will sort this array individually, and 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 then whatever array that I get from this particular array, this array, this array, this array, I have to concatenate them into one single array again. Like before I cut them into smaller arrays, I again need to concatenate them into a bigger array. And what the question demands is this particular array must be sorted. So following this entire process, what my objective is that I should maximize the number of chunks that I can break this array. Basically, the number of sub arrays which I have broken the initial array into. Now, the minimum number of partitions is obviously 1. Like I can say that, okay, let me just not make any partition. This entire array, I will sort it. Then the minimum number of partitions is 1. That is understood. What is the maximum number of partitions that I can make? Let's try to understand this with an example. Let's say my elements are something like this: 2, 0, 1. Just give me a 2, 0, 1. Sorry. Let's say 2, 0, 1. And then I have some elements, let's say 4, 3, 7, 5, 6. Let's say this is my array. Now my question is, can I make this particular partition? Let me just ask you this question. If I make this particular partition and whatever partitions that I make here, that won't matter. Why? Because when I sort this partition, what I would get is 0, 2. And let's say I get anything here. Let's say this particular portion is properly sorted: 1, 3, 4, 5, 6, 7. Now on concatenating this, would this be a sorted array? That is my question. Obviously not. Why? Because 2 is here and 1 is here. On the contrary, if instead of just taking 20, if I had taken 201, what would I have gotten? I would have gotten 0, 1, 2, and let's say this particular part I have properly sorted. So I would have gotten 3, 4, 5, 6, 7, which is a valid answer. Yeah. My question to you is, if if I have been given a particular array, and if I take out one segment of this portion, can I say this and say let's this is the x of x length? Can I say that this particular portion must contain the x smallest integers of the entire array, and I can separate this out to form one of my subarrays, and then I can guarantee you that of this part, making this partition would give me a valid solution. Why? Because in a sorted array, the x smallest integer would anyway come in this particular range. So even if I take this out, all the other elements would be undisturbed. And that is the entire logic that I want to apply. That is, I want to first separate out this particular subarray. Then I say that I have a valid solution here. If I have a valid solution here, then maybe I can again try to separate out the first possible subarray from this remaining portion. And I say this would contain the next, let's say the length of this subarray is y, the next y smallest integers. Now, why is that? Let's say this subarray did not contain the y smallest integers. If it had not contained the y smallest integers, then one of the integers that had to be a part of this subarray would have been missed out. And since this is a partition, and I won't be able to get this particular integer back. And similarly, there would have been an integer in this particular range which is not among the y smallest, it is greater than the y smallest elements which had to be in this particular range, and then that particular integer would have never been able to get into this range. So I can only make a partition if I can guarantee that in this particular range I have my y smallest integers. If I don't have my y smallest integers, then I cannot make a partition there. I hope this is till this much it is clear. Now the problem has has become very easy for a particular reason. And what is that reason? The reason is that I have been given a set of consecutive integers, and that also unique. Now we will study the problem whether what if it's not in range and what if it's not unique. But for now, let's visit this particular problem. Going on to my original problem that I had here, that is 201 43756. 43756. This is my ARR. Let's see what the sorted version of this would look like. It would look like 0, 1, 2, 3, 4, 5, 7, 6. And if I have to write down the indices of these numbers, I can say 0, 1, 2, 3, 4, 5, 6, 7. Just a mistake here. 6, 7. I think some of you may have noticed a pattern. What I'm trying to say is, if I say that in an array, if I have to make a partition here, can I say that the maximum value of all the integers from 0 to I will be equal to I? Only then can I make a partition. Why is that? What I'm saying is, if I have an element here that is greater than I, then let's say I have a 3 here and my I is 2. Then if I make a partition here, the 3 element would be trapped in here, but the 3 must come here. at the third index. That is a problem. But if I say my maximum that I could have gotten in this particular set of integers was 2 itself, then I say that if my maximum element that I have gotten is equal to I, then I can say that okay, I have a valid partition. All these elements in this particular range must be 0, 1, 2 in some particular order. I don't know the order, I don't care about the order, but it must be this particular integers. So I say I make a partition here and I can sort this array. I think that is something that you must be able to understand. What would the code of this look like? I say int val, which is, let's not name it val. Let's name it max underscore element, and I can assign a value 0 to it. And let's say my resultant value is 0. Can I say for I 0 to n minus 1, I say the max element that I have encountered till now, I need to first update it. Max of max underscore le comma arr of I, and I say if max underscore le equal I, that is I have found a valid partition point, then I say res plus plus and I close this loop and I return res. Let's try to dry run it. Okay, so I have this particular array 2014376. My max is equal to 0. I come here, my max becomes 2. My index is 0. I come here, my max is still 2. My index is 1. I come here, my max is 2. My index is 2. I make a partition here. I come here, my index is 3. My maximum element becomes 4. I come here, my index is 4. My max element is 4. I make a partition here. I come here, my index is 5. My max element is 7. 6, maximum 7. 7, maximum 7. I make a partition here. The number of chunks that I have is equal to 3, and that is the maximum that I can achieve. Let's try to code this up. I just say, int val like max underscore le is equal to 0, comma res is equal to 0, and I take the size of the array. And I say for int I is equal to 0, I is less than n, I plus max underscore le is equal to max of underscore le comma arr of I, and I say if max underscore le equal I, then I say res plus plus and I say return res. Let's try to run this solution. I'm getting an accepted. Let's try to submit, and you can see it's a submitted answer. The time complexity of the solution of one particular root is obviously order of n. The space complexity only using 2 or 3 variables, it's order of 1. But that's the simple part of the problem. Let's say I had been given any random set of non-unique numbers, not a permutation, not limited to any range, just a random set of integers. Let's say anything I was given 2, 3, 3, 1, anything, let's say 5, 4, 10, 9, 8. How do I solve this? The logic of the problem remains the same. Now, I have been given a chunk. Now, first I have to separate out the first chunk. I need to separate this out. Then I need to perform the operations on this particular array. Again, take out the first chunk. Then perform the operations on this particular subarray. The initial logic remains the same. But how do I understand that? How do I understand that? See, let's first sort this array, because whenever you are not being able to understand something, just sort the array. My end goal is a sorted array. So I take another array vec. I take another array vec which is equal to this particular subarray, and I sort this. I don't disturb the original array. What I say is 1, 2, 3, 3, 4, 5, 8, 8, 9, 10. All right. Now, how do I deal with this? In my initial problem, I said that whenever the max element is equal to I, then I would make a partition. Now, it was not obvious to you, but this meant one more thing exactly. Now, what it meant what is, if I have been given a sub array and I am saying that I am making a partition here. Let's say I have taken this particular sub array and I am making a partition here. Then I can only make a partition at the index I if for all elements from 0 to I, the correct index of each element is less than equal to 1. Maybe a bit confusing. Let's try to understand. I am saying I have 4 elements and at index 0, 1, 2, 3. And I say by some magic, I have calculated the expected index of each of these elements at these positions. And I say the maximum value of these expected elements is equal to 3. Now again, by the same logic, if I am saying that the if of 4 elements in a one based indexing, my maximum element maximum correct index is 4. Then at index 1, 2, 3 and 4, if one is maximum is 4 of 4 elements, then all the other 3 elements must go here. And I can sort, and the correct index must be among these 3 for all the other elements. And I can sort this array. Right? Works. So correct index calculate कैसे करेंगे? यार sort कर लिया. And I can say कि मैं एक मैप में स्टोर कर लूंगा MPP of 1. यहाँ पे मैं इंडेक्सिंग कर दूं 2, 3, 4, 5, 6, 7, 8, 9. मैं बोलूंगा MPP of 1 equals 1. मतलब MPP of 1 equals 0. 1 का एक्सपेक्टेड पोजीशन तो 0 है, यानी इसका एक्सपेक्टेड पोजीशन 0 है. मैं बोलता हूं MPP of 2 equals 1. मैं बोलता हूं MPP of 4 equals 4. MPP of 5 equals 5. MPP of 10 equals 9. भैया इन एलिमेंट्स का क्या करूं जिनके मल्टीपल करेक्ट पोजीशंस हैं? मैं बोलता हूं मिनिमम इंडेक्स असाइन कर दो. जो बोल रहा हूं उसको अज्यूम कर लो कि वो सही है फॉर नाउ. क्यों? आगे पता चलेगा. MPP ऑफ 3 को 2 बोल दो, MPP ऑफ 8 को 6 बोल दो. पता चलेगा क्या क्यों कर रहा हूं. देखो स्टेप बाय स्टेप चलते हैं. मेरे को एक ARR ऑफ I दिया हुआ है, ठीक है. मैं बोलता हूं इंट मैक्स अंडरस्कोर IND, मैक्सिमम इंडेक्स एक्सपेक्टेड इंडेक्स का बात कर रहा हूं, और मेरा रेज इज इक्वल टू 0, मेरा नंबर ऑफ चंक्स. क्या बोल रहा हूं? वेक्टर ऑफ इंट vec is equal to ARR sort vec dot begin comma vec dot end. और एक और स्टेप क्या होगा? फॉर I equals I 0 to n minus 1 MPP of vec of I equals मैप में स्टोर कर लिया एक्सपेक्टेड इंडेक्सेस ऑफ एलिमेंट्स। एक एक छोटा सा गलती आपको इसमें नोटिस करना होगा, हमने ये वाला स्टेप हम वी मिस्ड आउट ऑन दिस पर्टिकुलर स्टेप। सो फॉर दैट, for doing that we can simply say that if we have not encountered, that is if mpp dot count of arr of I equals 0, then mpp of arr of I equals I, right? चलो, सही एलिमेंट स्टोर कर लिया। अब देखो थोड़ा स्टेप बाय स्टेप ऑब्जर्व करो क्या करता हूं। फॉर I equals to 0 to n minus 1, all right, what I say is, I say I update my maximum expected index as max underscore ind is equal to max of max underscore ind, comma mpp of arr of I. And what I do next is something that you need to observe. I say mpp of arr of I plus, क्यों किया ऐसा? देखो, इसका करने का रीजन ये है, एक सॉर्टेड एरे में जो नॉन यूनिक एलिमेंट्स हैं, क्या मैं कह सकता हूं हमेशा एक साथ क्लब होंगे? थ्री हमेशा एक, अगर मान लो कि दो थ्री है तो दोनों थ्री एक साथ क्लब हुए, तीन होते तो तीनों एक साथ क्लब होते, दो जितने भी एट्स हैं वो एक साथ क्लब होंगे। मैंने इनिशियली थ्री को जो उसका फर्स्ट ऑकरेंस है उससे असाइन किया था, और मैं कह रहा हूं यहां पे मेरे को जब पहला थ्री दिखेगा तो मैं उसको उसके मिनिमम पॉसिबल इंडेक्स से मैप करूंगा, और मैं मैप की जो वैल्यू जो इनिशियली टू असाइन थी उसको मैं थ्री मार्क कर दूंगा कि भैया ये वाला तो यूज हो गया, ये वाला तो यूज हो गया, अब अगर कोई आगे थ्री दिखे तो उसको उसको इससे कंपेयर करना। दैट वाज द एंटायर लॉजिक ऑफ हैंडलिंग दैट, एंड आई सिंपली से इफ max underscore ind equal I say res plus plus, and I say return res. So first let's try to observe whether this particular solution would work or not. Now all these things remain the same, like just let me just change the name of this. I take another thing, I say vector of int vec is equal to arr of I, and I say sort vec dot begin comma vec dot end. What I say is I take a map of int comma int mpp for int I is equal to 0, I is less than n, I plus plus. I say max int is equal to max of max underscore int comma mpp of arr of I, and I say mpp of arr of I plus plus, and I say if max underscore int equal I, increment res and return res. Will this work? Let's see, run this solution. Okay, okay, so I don't need to assign arr of I, this should just be arr of I, and I have not assigned the values of map, so sorry for that. I is equal to 0, I is less than n, I plus plus. I say if mpp dot count of ar of vec of I equal 0, that is I have not encountered this particular element before, then I say mpp of vec of I equals I. Let's try to run this, and we see it's accepted. Let's try to submit this particular solution, and you can see that it's an accepted solution. Now let's try to run, let's try to understand the time complexity of this particular solution. So for sorting and constructing the map, this is an order of n log n operation. This is an order of n log of n operation, right? And accessing the map each time is a log n operation, and all the other things are an order of one operation. So for doing it n number of times, this particular loop will also be an order of n log n. Talking about space complexity, occupying an order of n space here and occupying an order of n space for the map also. So when I modify the constraints of the problem, the time complexity that I am getting at is order of n log of n, and this is my time complexity, and my space complexity is order of n. So guys, I hope कि प्रॉब्लम समझ में आया होगा पूरी तरह. कंस्ट्रक्ट ओरिजिनल प्रॉब्लम बहुत आसान है, बट थोड़ा सा मॉडिफाई करोगे तो इट बिकम्स अ बिट कॉम्प्लेक्स. इंट्यूशन समझना थोड़ा टफ हो जाता है. थैंक यू.